Good morning. All right, let's get started in just a second here. And we're going to continue on talking about sig figs. Today specifically, Oz, you don't have to groan and grumble. You don't hate sig figs. You don't have to do them. We're going to first talk about how to round significant figures. As we're going to see, since there is a good deal of mathematical operation that we're going to be doing with chemistry, it's important to know when and how to round numbers. Because if you just multiply two numbers together, for example, you may get something that has, 200 digits, right? But it's important for us to know kind of when to round and how to round. So, first, before we talk about when, we're going to talk about how. So, if I were to ask you, for example, round this number to, let's say, 4 sig figs. And let's say it's 1.264 whatever. Something you might get out of your calculator, right? Your number, your calculator will just keep spitting on digits until its window is full, generally, right? Unless it's an even number. So, if I wanted to round this number to 4 sig figs, this is how we're going to do it. We're going to start counting the significant digits from the left. And the reason for that is because, as we saw last time when we were measuring that, was it a B? I think we did. You saw that kind of like that first number was the most vague, and then we kept adding more and more significant digits the more our kind of instrument got better. So we're going to see that numbers on the left side, like the ones place in this example and tens place, those are less precise. So those are the ones we have to keep. The ones that we go farther and farther along with, remember that this one is uncertain, for example. But that gives us more precision. So if we're rounding the number, we have to keep the least amount of precision. So in this case, it's going to be those 4 digits that we're going to keep. All right, and those are also the biggest digits, right? I mean, if we were to just round the last ones, we're losing out most of our measurement. We're losing, I mean, if we were to just say 0.004024, that's not so helpful. But 1.264, that's essentially what we're looking at with this number, right? We may have some extra stuff that's helping it out, but those are the most important numbers for us. So, if we were to just round this number, in this case, it's simple. We would then look at the next digit after the one that we're not keeping, and then we have to see it is greater or equal to 5. If so, we round up. In this case, it's a 0, so we're going to round down, which means we don't change anything. So this number becomes 1.264 if I wanted to round this to 4 sig figs. All right, so something you've probably done in elementary school when you started learning rounding in the first place, but we're going to really make sure that we have a solid grasp of it because it's going to be an important thing that we deal with for the entire semester and then beyond. So for those of you who continue on in chemistry, especially if you're doing Gen Chem 1 or 2, you're going to be dealing with sig figs all the time. So it's important that we keep those. Alrighty, so that's one example. Let's do another. Let's round this one to 3 sig figs. All right, so if we want to round this one to 3 sig figs, Do I want to put something like this on you already? Yeah, I kind of do. Again, we're gonna want to we're gonna have to keep three numbers here, right? So for right now, we might be like, okay, well, this is what we have to keep, the leftmost numbers. Remember that 0 at the start is never significant, so we don't have to worry about that. Although we are going to have to worry about that place in just a second. Because we see now, we're going to look at the next number. It is indeed greater than 5, which means we're going to round up. So that means we're going to add 1 to our kind of last significant digit there. And so now that becomes this number once we have rounded up. But now it's back to 4. So we just need to kind of trim a little bit of off the number here. So again, we're going to look at this and we're just going to say, okay, this extra 0 here is just adding a sig fig to our number. And so if we wanted to round this number to 3 sig figs, we should end up with 1.00. And that will have 3 sig figs. Remember, those zeros at the end are significant because there is a decimal in this number. Remember, that's the rule for ending zeros. All right, so that's why we kind of cut off that 0 there. All right, to make sure that we still had 3. All right, let's do another one. Let's round this one as well to 3 sig figs. 126,802. I've been using light blue. We'll be consistent with this. So again, we need those 3. And we look at the next one. We say, okay, that number is greater than 5 or equal to. And so we're going to round up. And so we might be tempted to say, okay, it's 127. But there's a problem here. This number is somewhere in the 100,000 range, right? This is 100,000, 126,000, whatever, right? This number here is 100. If you were rounding your paycheck, for example, and you are very fortunate and you somehow make $126,802 and you are for some reason taking chemistry, good for you. But you'd be pretty mad if, they said, okay, we're going to round your thing up. And now you have $127. You'd be pretty mad, right? So what we're missing here is some place-holding zeros. These zeros are super important because they're going to make sure that our original number's magnitude, how big our original number was, is very similar to the magnitude, how big our rounded number is. So it's important that we have those placeholders there. And note, because there's no decimal, those numbers are not significant. So 127,000 written like this still only has 3 sig figs. So we're not breaking any sig fig rules by doing this, but it's important that we have these placeholder zeros so that we don't lose the sense of how big our number was. So don't forget those. So just keep those in mind, okay? So on the homework assignment that is posted, you'll have some rounding practice like this. All right, so hopefully none of this is too crazy. You've probably been rounding, all your life, so just putting the rules out in place here for you guys. Alrighty. Any questions on those? There we go. Alrighty. And so, we now come to probably the first confusing bit, I'd say, of this course. Although it's not terribly confusing, students do tend to get confused with this. So, let me just reiterate that. So, we're going to see that when we're doing math with measurements, anytime we're doing any sort of mathematical operation, we're going to have rules for when to round numbers and also where to round them. So, like, well, let's just see. We're going to see that there's kind of three categories of rules. The first category is for multiplication and division. And this will be the easiest one. And luckily for us, this is, 99% of the stuff we're going to be doing in this class is multiplication division. So this is going to be the most important rule, and thankfully it's the easiest. So you are going to, when multiplying or dividing, numbers that have been gotten from some sort of measurement, which is really basically anything you'll be given, the rule is you keep the smallest number of sig figs in your answer. And let's take a look at what that means. So let's say I have driven in my car 47.2 miles with 1.0 gallons of gas. Clearly this is like a hybrid car, right? If only we could get these in normal things. Okay, I can't say 1.0 though because that's just a boring math. Okay, let's try this again. 1.1. All right. So if we take a look at these numbers, these are both measurements, right? So my car or whatever has measured that I've gone 47.2 miles by doing some sort of calculation with its wheels or whatever. And the 1.1 gallons is a volumetric measurement, right? So those are both measured numbers. And so if we do this math, I don't even have my calculator. Shame on me. Okay, I'm going to use Google. 47.2 divided by 1.1. By the way, good thing to do to get into the habit of is doing these calculations, whether you're here right now or watching the video later. I'll do all the calculations for us. I'll have all the numbers, but it's still a very good idea for you to do it yourself on your calculator or whatever you're going to be using to calculate with, because, believe it or not, one of the biggest things that students tend to overestimate is their ability to use their calculator. Because, in an exam environment, things are, stressful, and all of a sudden you're like, oh crap, where's the times 10 to the button on my calculator? Oh no, I'm going to spend 3 minutes now looking for it, and that's 3 minutes wasted, right? So it's always a good idea to follow along and do these calculations as I'm doing them. Because the more practice you have, the less you'll have to worry about it when the time comes. All right. So, by the way, when we do this, we get 42.9090909090, whatever. We'll say 1. This is the number we get out of our calculator. Gives us this number. And so, not a terribly, or this is an extremely precise number, right? It has 20 sig figs. But we have to take into account that our measurement devices have limitations, right? Whatever measured our miles and whatever measured our gallons, those instruments have sig figs because, someone has paid for them and they've done their job measuring. What we want to do is take a look at the numbers that we actually were dividing and see what those sig figs are, and then we have to choose the smallest number, and then we're going to round our final answer to that number. So let's take a look. So the top number here, 47.2. There's no zeros in any of these numbers, so thankfully that'll be nice and easy for us. That number is 3 sig figs. 4, 7, and 2, all significant numbers. This number here on the bottom, 1.1, is 2 sig figs. So we need to round to 2 sig figs. We're always going to choose the smallest number when we're multiplying and dividing. Alright, so if we're to do that, we're going to say, aha, we must keep the leftmost two significant figures. We're going to look now at the next one. It's a 9, which means we round up. And so our final answer here will be 43 miles per gallon. Our units are still the same. They don't change. All right, so our final answer for this is this number here. And having those 2 sig figs there lets other people know that that is how certain our measurements were that went into this calculation. So if you have a very fancy gas tank that has 1.102 gallons or some very precise one, you'll be able to have more in your final answer. But it just depends on how good your measurements are. So, and again, since everything in chemistry we're dealing with is measured, the sig figs are super important for just keeping that information. Okay? Same thing for dividing. I'm sorry, multiplying. I guess we should do that. Let's see. Let's do maybe some volume thing. Let's say a cube has sides 26.4 centimeters, 10.3 centimeters, and 102.2 centimeters. What is its volume? Just so you remember, for a cube, volume is length, width, and height. I'm not going to give you any crazy, here's a cylinder and do your pi r squared h stuff. Don't worry. If we're ever doing something like this, it'll be a simple formula like this. You don't need to memorize this, by the way. Don't ever worry about geometry formulas here. So, but this is an example of when we might multiply numbers together, and these are, as you can see, are all measurements, are all lengths. So someone has taken a ruler and measured this cube. I guess it's not a cube; it's a rectangular prism. Rectangular prism. A cube has to have equal sides, right? So clearly, this is not a cube. But anyways, let's go ahead and do this. If we do these numbers, 26.4 times 10.3 times 102.2. 26.4 times 10.3 times 102.2. Also, another good reason for you guys to be doing the calculation is sometimes I punch in the wrong numbers, and I don't want anybody to get confused if I come up with the wrong number by doing the math here. So just another good reason. So if you do find something, just write it in chat, be like, hey, I got this instead, and we'll check it out. All right, so with this, we get this number. By the way, with units, don't forget if you're multiplying things, you still multiply the units too. So in this case, we have centimeters cubed is our unit here. Because centimeter times centimeter times centimeter is centimeter cubed. So just don't forget that part. Anyways, but obviously this number we get out of our calculator is too many sig figs, so we're going to want to take a look at all of the numbers we multiplied and be like, aha, this one has 3 sig figs, and this one has 3 sig figs, and this one has 4 sig figs. We always choose the smallest number, so we are going to round to 3 sig figs. Goodness gracious, it seems everything has a 9 after it. Not intentional, I am just making these numbers up. So, but again, a 9 higher than 5, so we round up. So this number becomes 278. Don't forget your placeholder zeros. Since that was 27,000 earlier, we still should have 27,000 in our final answer. And we keep our unit, and that is going to be our final answer there. All right. Questions on that one? So again, multiplication, division, you will count the number of sig figs in each of the numbers you're multiplying or dividing, and you're going to then round to that number later. Let's do one more example of something we're going to see soonish. What's a good one to do? Okay. Let's say I have 2,082 inches. This is not the best example, I realize, but oh well. So, doesn't matter if you're multiplying and dividing at the same time, no problem. In this case, the dividing doesn't even matter, but it will matter for our sig fig purposes. Though this is, as we'll see later when we talk about unit conversion, this is a bad example on my half, but we'll talk about that later. For right now, just look at the numbers. Don't worry about the units. But we'll deal with that later. Okay, so with this, maybe we should worry about units. Okay, never mind. Let's just do the math. So, if we're going to take this, we're going to do 2,082 times 2.54, technically divided by 1, but we don't need to actually put that in our calculator because it's divided by 1, who cares? But we'll see that might be important later on. All right, so we get this number out. I didn't want to do this yet, but look at the units here. Inches divided by inches actually will cancel out. And so we'll be left with just centimeters here. This is something we'll do later on. But just remember, if you have inch over inch, that just becomes 1, right? Anything divided by itself just cancels out. So, anyways, we'll talk about that later on. Let's look at the sig figs here. So, first number has got 4 sig figs. This number on the bottom has got 5 sig figs. Right, all 4 of those zeros count because there is a decimal. And this number on top has 3 sig figs. And so of all these 3, we're going to need to round to 3. And so, again, we're rounding up. Eventually we'll round down, I promise you. But it seems that every time we have a high number in our next position. So we're going to round this to 5290 centimeters. We need that placeholding 0 there to make sure we're still 5,000. All right, so that would be our answer here. All right. Any questions on that one? Alrighty. In that case, let's talk about the next part here. So, addition and subtraction are going to have a different rule. So with multiplication and division, we took a look at how many sig figs were in all of the numbers we were multiplying and dividing. And then we chose the smallest one and rounded our answer accordingly. With addition and subtraction, that's not the case at all. We do not care how many sig figs our numbers have. We are going to have to round to the least significant digit in the numbers added or subtracted. And that might be a little bit strange. So we don't care about how many sig figs we're dealing with. We're caring about where that significance is. And if I were to talk about it a little bit, let's say I have 2 elephants now. Remember last week I had just one and we measured it and all that? Elephant 1, let's see, computer, how much does an elephant weigh? How much does an elephant weigh? Let's find out.
An elephant typically weighs between 6,600 pounds and 12,000 pounds when fully grown.
Okay, cool. So we have, let's say the elephant 1 is 11,820 pounds, as according to my crappy scale at home. And remember, elephant 2, we took over to NASA, and they had the very fancy scale there. And let's say that one came in at 6,903.24 pounds. All right, and so if I want to say, like, what is the total weight of my elephants, we'll need to add them up, right? It's a total. But one thing to note is that this number here is less precise than the other one. And so as a result, our answer needs to convey the fact that for one of my measurements, I used a crappy instrument. It's not to say it's crappy, but it's not a precise instrument, which I guess means crappy, but that aside. This is the way to do this for us. What you want to do is you'll want to line up, actually let me do it in a different color. You'll want to line up your numbers that you're adding as if, you were way back when you were first learning to add. You'll want to line them up and add them kind of vertically. This is going to be the easiest way to do it. So we're adding these. And so there we go. That's the number we get when we do this. If you would plug it in your calculator, you get the same thing, but when it's like this, you can do it manually, but it doesn't hurt. What we want to do, though, now is take a look at how accurate or how precise our original starting numbers were, and we have to convey that information in our answer. So, the first number has its last significant digit right here. That's the last significant digit. So, I'll write that here. So my measurement was only able to go to the tens place with that elephant. And my NASA weighed elephant gave us to the 0.01, the hundredths of a pound. Right? By the way, these are pounds. We should keep our units there. And so when we're looking at this, the way that this works for adding and subtracting is we are going to choose our least significant number and we're going to round it to the same place. And how that's going to work is you see that this one is in the tens place. So 20, there, that 2 is in the tens place. That's where we're going to round our final answer. So I'm going to just draw a line down to indicate, okay, all the stuff on the left we're going to keep. All the stuff on the right we're going to round away. And so, if you want to think about this in terms of number of sig figs, in this case we're having 4, but that's not the important thing here. You don't worry about how many sig figs you have. You worry about where that is. So, with this, we're going to end up saying, okay, we keep 1872. We look at the next digit, it's a 3, finally something less than 5, which means we round down, and so it just becomes a 0. All right, so we're not going to change that 2 into a 3. We're going to leave the 2 as a 2, and then we keep our placeholder 0 there. All right, so this is how addition and subtraction work. Again, the idea here is to make sure that we are conveying the significance of our measurements using these rules for rounding. All right, so when you do this, you're going to kind of cut off your number at your least significant digit in any of the numbers you're adding and subtracting. And you're going to keep everything on the left and round away everything on the right. We're going to do quite a few more examples because I understand this is a little bit less obvious. This one, it's easier to actually write stuff out than it is to say, okay, well, we got tens place and hundredths place. Well, tens place is less significant. We should round our number to the tens place. That can be a little wordy and troublesome, so it's easier to just kind of set it up this way. Let's do some more. Okay, so we have now 3 numbers we're adding. I could subtract 1 if I wanted, but let's just add them all. Who cares? We'll want to set them up. So 22.6, 0.86, and then 104.9. All right, we're adding all these up. So we get 6, 3, carry the 2, 8, 2, 1. All right, so I can do the math, hopefully. We now want to take a look at all of our numbers and see where their last significant digit is. In the top number, it's the 6. In the second number, it's the 6. In the last number, it's the 9. Right, so we're just finding the last significant digit. And now we're going to go ahead and decide where to round. So we choose the least significant digit of our numbers. In that case, the 6 and the 9 are equally least significant. That's where we're going to kind of do our cutoff. So it's always right next to our least significant place in the numbers. And so again, we're going to keep all this stuff, and we're going to round this stuff. And so with this, we're going to keep 128 point. In this case, notice it's a 6, which means we're going to round up. So we round this one up to a 4. And what was our unit? Centimeters, I guess. So adding units, remember, is the same thing. So in this case, this will be our final answer, 128.4 centimeters. All right, so again, it doesn't matter that, how many sig figs we have. We're looking at where the significance is. So we go with our least significant measurement. Our least significant measurement was at the 10th place. Sorry. So our answer will also be significant to the 10th place. So that's the important bit here. All right, so again, doesn't matter how many, matters where. So keep that in mind. Okay? One of them is whining to get in. 1 second. Take a moment to think about this. Come on, Rooney. Come in. Come on, buddy. You don't have to cry outside. There you go. Go figure. Okay. So, hopefully that is acceptable. I think, though, it is time to blow your minds away. How about this one? Let's say I have 100 calories minus 1 calorie. All right, here we go. 100, 1. I can do this math. 99. Let's look where our significant digits are. In the top number, this 100, it's a pretty crappy measurement, so that 1 is the least significant digit there. Those zeros don't count. Remember, they're not significant because there's no decimal. And here it's the 1. So we're going to cut our number off at the least significant place. So we're going to keep nothing, presumably. But we take a look at the next one. It's a 9, which means we round up, which brings our final answer, therefore, to 100. So, you are welcome to go into your math class and say, well, I just did 100 minus 1, and the answer is 100. Oz, what are you doing? He's like choking himself to death, just standing there. He does that a lot, so it's not a cause for alarm. Yes, I told you it'd blow your mind. So, this measurement here, being so imprecise, gives us an imprecise answer. So, consider if I were weighing my elephant. I'm just trying to put this into context for why this would make sense. Why 100 minus 1 could be 100. So keep in mind, I'm measuring my elephant, right? And my elephant is extremely well trained, and I instruct it to kind of hold its breath, right? And so it's being weighed, and it does that, right? And somehow I'm able to then say, okay, now exhale, and I'm going to capture all that air that comes out, and I'm going to weigh that air, right? Compared to the mass of the elephant, which was 12,000 pounds or whatever, the weight of the air that comes out is 0.00001 pounds, something like that. And so if I were to say, okay, if I were to go put my elephant back on the scale and say, okay, this time breathe out, the scale's not going to read anything different. Despite the fact that there is a change in mass, a change in the amount there if the elephant has breathed in or out, right? The air inside the elephant's lungs does weigh something. It just weighs very little. And so you know, the idea here is that if the elephant if the elephant weighs 100 and breathes at 1 pound, it's kind of a terrible example. And maybe the elephant weighs 10,000 and breathes at 1 pound. Is that really a big difference? Not really. The elephant still weighs 10,000 pounds. So that's the idea here, is that when one measurement is so much larger than another but is imprecise, our final answer is going to be equally imprecise. So let's take another example. So let's say we're in person and I look around the room and I'm like, okay, there's 100 of you in here. And then someone decides to walk out of the room. If I look around, I'm just going to say, okay, yeah, there's about 100 of you in here, right? It doesn't matter if it was 109 people in the room or 92 people. I've kind of just guessed that it's 100. And so by having one person leave, it doesn't really change my estimate, because I didn't actually count anything. I just took a vague glance. I'm like, okay, there's 100 of you here. It's a pretty crappy measurement, right? And so if one person leaves, I'm probably not going to notice. I mean, I would notice, but it would not change my measurement. I'm not going to say all of a sudden now there's 99 people, because 99 is a more accurate number. It's more precise. When you say there's 100 people in here, it is unlikely that we've actually counted one by one and figured out there's exactly 100 people here. So that's the idea behind this. So I'm not just doing this to torture you. Okay, well, let's not rule that out. I am probably doing this to torture you, but there's a reason for this. All right, but don't worry. Most of the adding and subtracting we're doing in this course is only for temperature. And that's just converting Celsius to Kelvin. That's really pretty much the only addition subtraction we do in this course. For the homeworks and stuff, yeah, you're gonna have some problems where you do this sort of thing, but later on, this is gonna become less important. We're gonna do much more multiplication division than anything else. All right, let's do one more example. So let's say I have my thermometer. Gives me a temperature of 67.2 degrees Celsius. Yes, I am honest. All right, and I want this number in Kelvin. And so just remember, Kelvin is your degrees Celsius temperature plus 273.15. So if we wanted to convert this temperature into Kelvin, we would just need to add them. So we'll say, okay, we've got 273.15 and we've got 67.2. We do this. Okay. No, 3. All right. Choose our least significant digits. Those are those two. The last digit in your number, basically, that's significant. As a result, we're going to round accordingly here. Always right next to your least significant digit, so that's the 2 there. We're rounding right next to that number. So by doing this, we get 340.4 Kelvin. Notice again, one number was 5 sig figs, the other was 3 sig figs. Now we've ended up with a number with 4 sig figs. That does not matter for addition and subtraction. So only apply multiplication division rules when multiplying or dividing. All right. Here we have addition and subtraction. All right, and as a result, we are going to follow addition and subtraction rules, which tell us we round to a particular place. We do not care about where that place is. All right, we just follow the rules. All right, so there will be practice on this. So don't worry. You'll have plenty of homework to work on this for. All right, any questions on any of these? I know it's not so obvious. Okie doke. Let me show you the last one. The last case is for logarithms. For now, I say don't worry. We're not going to see logarithms until the very end of the semester. So with these ones, I'm going to introduce it here. I think there's one question on your homework that deals with the logarithm, and then you can forget about it until chapter 11. So, I'm sorry, chapter 11 for 101 people. For 111, you're not going to use logs at all this semester. You'll use them next semester. But the rules for logarithms are a little bit strange. Only numbers after the decimal can be significant. So that's the rule. So if you say log, I don't know, 10.2 or something, you're going to get an answer out. Let's see, log 10.2. We get 1.0086. Okay, and there's a bunch of other zeros, who cares? For logarithms, we are going to keep the same number of sig figs that we had. This number here has 3 sig figs. So we need our final answer to have 3 sig figs. The tricky part about logarithms is that anything before the decimal does not count. And that's because of the way logarithms work, right? So in fact, when we're looking at this number, if we want it to be 3 sig figs, we're only looking at things after the decimal point. So we're going to round this number. We get 1.009. And that is 3 sig figs. All right, so the 1 does not count for sig figs. 0.009 does. Those are the 3 sig figs that we have there. The reason for that is because of the way logarithms work. They present a number as a decimal, but the number before the decimal is actually the power of 10 that it is. And then the stuff after is actually from the logarithm itself. So don't worry about this. I'm introducing it now. Don't worry about it. You'll have one thing on your homework. The homework does have the rules right above it, so you can reference them. So you're still going to keep the same number of sig figs as the number you plug into your calculator. But when you're rounding your number, just ignore stuff that's before the decimal. So just leave it alone. That doesn't count for your sig figs. All right, and then with that, don't think about logarithms again until the very end of the semester. So put that out of your brains because I don't want you to get confused. More so than is necessary. So, okay, so that's there, but again, don't focus on this. Alrighty. Shall we take it one step further? I think we should. Perhaps it is important that we do this. So, if we're combining operations, for example, something like this. Anytime we have combined operations, we do not round until the very end. So, because addition and multiplication have different rules, we do need to obey those rules but we are not going to actually round our number until the very end. The reason for that is because every time you round, you introduce a small amount of error into your number. And so if we keep rounding things, that just keeps adding more and more errors. That's going to throw our measurement off. And so if you're working at NASA, building your rockets or whatever they do there, if you keep having a lot of error in your, numbers, that can lead to pretty bad problems, right? You don't want to, take any chances messing around. So it's important that we don't round our numbers until the very, very end of the problem. All right, so if we take a look at this one, we have an order of operations to follow, right? Don't forget this. Please excuse my dear Aunt Sally, or PEMDAS. That's our order of operations. So we do parentheses, we do exponents, we do multiplication, division, and then we have, what is this, addition, subtraction. So that's the order of things that we do, right? So looking at this, we have some parentheses and then a division to deal with. So we have to follow this order. So first thing first, let's do that addition. If we're adding these up, because this is the part in parentheses, right? That's the part we have to do first. So we do this, and we have that. All right, although we are not going to round, we're going to see that we're going to pretend as if we are going to round. We're still going to do this stuff and say, okay, if we were done, if we did round, it would be to 16, right? That's how we would round this number for our addition rules. But we're not going to. We're not going to round it. Because step 2 that we're going to do here, we're going to plug that in. We're going to say 16.2 over 4.99. So we're going to, we're still doing this problem, the problem that I've put out here. We're just doing it step by step. What's important, though, is that if we did round this number to 16, although we aren't going to round it yet, that number would have 2 sig figs, right? Because this next part we're doing is division, and division we care about how many sig figs, right? So if we pretend we rounded it, that number would have 2 sig figs. It would have 2 sig figs after rounding, but right now we just want to keep in mind that it should have 2 sig figs. And this number here on the bottom has 3. If we do our math, 16.2 divided by 4.99, 3.24649, whatever, bunch of other stuff. Although we did not round that number to 16, we kept it at 16.2. We knew in our brains that that number should only have 2 sig figs. And so our final answer here is between 2 sig figs and 3 sig figs. Division rule says take the smaller number. And so now that we're done with the problem, we've done every mathematical bit we need to. I'll answer that in just a second. We're going to want to round this to 2 sig figs, which will give us 3.2. Okay, so why is it 2 and not 3? So, if this were a standalone problem, if I were to just tell you, okay, add 10.2 plus 6, do that. If you did that, you would get 16 as your answer with the appropriate sig fig rules. Is that part okay? So just the same thing here. That's why we got 16. And so this number here has 2 sig figs. After we round it to the 10 ones place. So we are kind of pretending to ourselves that as if we rounded that number, it would have 2 sig figs. Because the rules for addition says we must cut it off at the ones place, so that would have 2 sig figs. But because we don't want to round it yet, we're going to just say, okay, well, it should only have 2, but we're going to keep the number intact until we finish our entire problem. So that's why. We're going to do more of these so that we can see how it works. So we only round at the very, very end once you've done your last little thing. And so the last step was multiplication or division. So the last rule we follow is the number of sig figs. Let's do another one. Let's say we have 108 divided by 16 plus 3.14. Why not? Here's another problem. So, following our order of operations, we're going to do the division part first. 108 divided by 16. Oops. We get, well, that's convenient. Okay, we get 6.75. If we do this, 6.75. But before we go ahead and do our next step, we have to keep it in our brains where or how we should have rounded this number. So division rule says we look at how many we have. So top number has 3, bottom number has 2. So this number should only have 2 sig figs. Right, so if we were to round it, we would say 6.8, right? If we were to just go ahead and round that, and it would have 2 sig figs, right? By being 6.8. But we're not going to round it yet. But we're going to understand that if we were to round it, that's where we would round it. For division, yes. So for this part of the problem, that's division. And so for that one, we go with the number. But now we're going to go ahead and do our addition and subtraction, and we'll see what's going to happen with this. So now that we have our divided part done, we're adding these two numbers. Now we care about where things are, right? So the 3.14 obviously will have the 4 as its least significant digit. But we have to remember that we would have rounded, had we been done with the problem, we would have rounded that number, the 6.75 to 6.8. We would have rounded it, even though we're not going to. That's where we would round it. And as a result, that's where our significant digit would be, had we rounded it. All right, so remember this number here that we calculated, had we rounded it, if we just said 6.8, it would be the 8, right? That's the last significant place. And so we keep that same idea, but we don't round yet. All right, remember, rounding early can lead to errors. So sometimes it does, sometimes it doesn't. We're going to avoid ever doing it. So we will not have any errors added into our thing. So when we do this, we're going to go ahead and do our addition. And so we're going to now look at our next number, and we're going to round this to 9.9. So again, we are pretending that that number is 6.8 at the top there. And since 6.8, I mean, so if it were 6.8, we're going to see we will end up getting the same answer, but it's a bad practice. You should not do that. So if we were to pretend 6.8 plus 3.14, let's say that 4 was a 5 or something, then we would end up messing our number down. We're done with 10.0, right? And so that's a problem. In this case, it wasn't a problem, but it could be a problem. If we were to just do these, hopefully here you can see, oh yeah, well clearly it's the 8, and we're going to round it there, and there we go, 9.9. But this angry red is naughty. Don't do that. Don't round it. So I kind of did an underline here in my number to say, well, that's where I would have rounded it. And so I was keeping it in my head where I should have rounded that number. And so that tells us where to put the significance when we're doing our adding and subtracting. Okay. We'll do more. Don't you worry. Here's one that's pretty common that we're going to see later on. Let's say that we're doing okay. This one is something that we'll do often. We're going to see this will be solving the ideal gas law. In this case, for what would this be solving for? Perhaps volume or something. Anyways, this is something that we'll see where we'll have addition and subtraction and multiplication at the same time. And division too, why not? So follow your order of operations and don't round yet, but pretend you did. So we have multiplication, parenthesis, and division on this. So we're going to go ahead and do our parenthesis part first. So let's go ahead and do this part. This part is first. So let's do that. If we do it, 26. $299.15. If we were to round this, we would round it right here. And so that would be kind of our last place here. So if we were to round this, since next we're doing multiplication, now we care about how many sig figs this has. This should have 3 sig figs. if we were to round it. If we're just looking at this number, it would be 299. 299 has 3 sig figs, but we're not rounding yet. So it would be 299, right? If we were done with the problem, it would be 299, but we're not done, so we don't round yet. But now we can say, I'm actually just going to copy this. I'm going to just move it down here. Now that we've done this part, I'm going to put it in our light blue. But we're keeping in mind that this number has 3 sig figs. All right, again, if we did round it, it would be 299. And so that number has 3 sig figs. All right, as written, yes, it has 5, but we're pretending that that part doesn't exist, even though we aren't rounding it away. We have to keep it to make sure our calculations are correct. All right, so we can't round it away, but we pretend we did for sig fig purposes. All right, and so if you look at the rest of these, we have overall, we're going to end up with 3 sig figs at the end. So let's go ahead and do it. What do we have here? 10.2 times 0.08206 times 299.15 divided by 18.9 gives us, we do this fun stuff, 13.2482 whatever. And so if we round that to 3 sig figs, that'll be rounded to 13.2, whatever it happened to be, unit-wise. All right, so the idea here, follow your order of operations, use whatever rules are applicable. So we did addition this time, so we need to follow addition rules. Then follow the rules of the next operation. For the last operation we did here was multiplication division, so we follow our multiplication division rules. All right, and we do not round our answer until the very, very end. And so that is our answer here. All right. Take a moment, breathe. I get it. It's complex, but trust me, with practice, it's not going to be a problem. This stuff will become second nature to you. So, I mean, oftentimes, you hear the stories about students, having nightmares about sig figs. This is where those come from. You're going to be crying in the shower thinking about sig figs. And that's normal. Don't worry, you're not alone. It's because it's not terribly intuitive, it can be tough. I get that. So, but the best way to do it, practice, practice, practice. Your textbook has plenty of examples of these. So whether you're in 111 or 101, and honestly, whichever textbook you're using, you're going to see plenty of rounding problems for your sig figs in there. You may want to, if you feel you need more practice, choose some of those that have answers in the back of the book, and then you can check your answer with those. And if anything says, hey, I was doing this problem and I can't get the right answer, take a picture of it, post it in Discord, see if your classmates can help out or I can help out. And so, ask for help if something is not working out. So that's what I would recommend doing. All right. And again, our Discord is a great place to do that because, you're all in this together, right? You're all here learning chemistry. And so, don't ever feel ashamed for asking questions in the Discord like that. So And by all means, if you see people asking for help, please feel free to try and help out. That'll help both of you. So important things there. Okay. Any questions on these last couple of them? All right. We have one last little bit here. Which is going to be a way to help us with our sig figs somewhat. We're going to see that scientific notation is a way to kind of communicate very large or small numbers easily. And how it's going to work is you're going to have some number, just one number, I realize there's X's everywhere. It's going to take the form of this. You're going to have a single digit before your decimal point, as many digits afterwards for significant figure purposes, and then you're going to have a power of 10 associated with it. Let's take a look at what this is going to look like. So for example, we had that 127,000 number earlier. If we wanted to put this into scientific notation, we want to, we essentially have a decimal right here, right? That's where it is, even though it's not written there. That's where it would be. If it were written there, those zeros would be significant, right? But since we are pretending that there's a decimal here, those are not significant zeros. If we wanted to convert this number into scientific notation, we would just need to move the decimal so that we end up with one number before it and all the rest of the numbers afterwards. So if we do that, we have to move it once, twice, 3, 4, 5 times. And therefore we end up with 1.27, keeping all of our significant digits from this number. And since we moved it 5 times, we have 10 to the 5th as our power. So it's a way of talking about this number that's fairly large, 127,000. And we are going to make it into an easier number to visualize. So 1.27 times 10 to the 5th power. These numbers are mathematically equivalent to each other, right? I haven't changed the numbers. But notice I've gotten rid of those pesky placeholder zeros. The zeros that give you the trouble of thinking, oh, is this zero significant or not? Scientific notation only ever has significant digits. So we don't have to worry about those here. So if you're ever, wondering, is this zero important or not, put your number in scientific notation. And then you don't have to worry about it anymore. So it makes things a little bit easier for you. So notice that this was a big number, right? Bigger than 1. And notice we have now a positive exponent. So if you have a big number, a number that's greater than 1, your exponent will be positive for your power of 10 there. If we had something else, say smaller version of this number. Well, we could do the same thing. We can put this in scientific notation too. But this time, remember, we need one number before our decimal. Can't be a 0, so it has to be a regular number, 1 through 9. So we're going to have to move our decimal over. So 1, 2, 3 times, in this case. So that's 1.27. Again, we're keeping all of our significant digits in our number here. And this time, our power is going to be negative because we have a small number. And so we're going to end up with a negative exponent. We move the decimal 3 times. So our exponent value is 3. And because this number was smaller than 1, it's going to be a negative 3. All right. Hopefully that's not too bad. I'll write this out. So we have a small number this time. That means it's less than 1. That's greater than 1. Let me try again. It's less than 1. So we have a negative exponent. So putting numbers in scientific notation is not that difficult. You will move your decimal such that you end up with one number before the decimal, as many numbers after as you need, and you'll have some exponent with your 10 there. Big numbers have positive exponents, small numbers have negative exponents. Big numbers would be greater than 1. All right, let's do another one. If we want to put this number in scientific notation, big number, right? Bigger than 1. So we are going to end up having a power of 10 that is positive. So we need to move our decimal. We're moving it to the left this time. 1 spot. We keep everything that's significant. So that's all of those numbers. And we moved it once. So it's 10 to the 1 is our exponent. All right, hopefully nothing too crazy. Again, you don't really cut off things. The only thing you'll get rid of is placeholder zeros. So the zeros at the end of this number were placeholders. The zeros at the beginning of this number were placeholders. Those all went away. We're keeping only significant values. That 0 was significant in our number to start. It stays significant in our answer. Sometimes scientific notation is the only way to have a number with the correct number of sig figs. So let's say you had the number 999, and you need it to have 2 sig figs. If you were to do that, we would round it to 1,000, right? But we need a way to say, okay, we know that we need these 2 to be significant, but not the other 2. If we throw a decimal on, if we say, okay, we're just going to put a decimal, well, now all of those zeros are significant. So with no decimal, it's 1 sig fig. With a decimal, it's 4 sig figs. So we have a problem here. If we need this number to have 2 sig figs, we're going to have to put it in scientific notation. And how that will work is now, okay, well, this is where the decimal would be. Its power is going to be 3. We're going to have 1.0 times 10 to the 3. We keep as many sig figs as we need, right? So if I've asked you to round this number to 2 sig figs, your scientific notation can have 2 sig figs. You can put as many zeros as you need to make things significant. If I wanted it at 3 sig figs, well, we wouldn't round this number then, but if I wanted it 3 sig figs, look, poof, there you go. Now it's 3 sig figs. So, scientific notation, everything in the number is significant. So, since this case I asked you for 2, we'll keep it as that. One thing to note, this stuff does not count for sig figs. The times 10 to the whatever, that's we don't count that for sig figs. So just so you know. Well, actually, we might as well do an example. If we multiply or divide stuff with scientific notation, we can do that too. We can do that with regular numbers or with scientific notation numbers. If we had those 2 numbers to start with, oops, we had those first 2 numbers, the 1.27s. We can multiply those together. Easiest way to do this, by the way, is to kind of rearrange things a little bit. Because, hopefully you remember your exponent rules. When you're multiplying things with exponents, all you have to do is add them together, right? So this is just 10 to the second power. So we've already taken care of that part, and now we can throw the rest in our calculator. You could throw the whole thing in your calculator too, but it'll save you some time if you handle your powers of 10 a little bit separately. So if we do this 1.27 times 1.27, we get 1.6129. And that could be our answer. Could be, but it's not, because of sig figs. Those 1.27s both have 3 sig figs, so our final answer should have 3 sig figs. Remember, the 10 to those do not have significance, so we don't worry about them. So our answer needs to have 3 sig figs. So we're going to round our number. Yes. You thought you were done with sig figs? Never. Never, never. So our answer there will be 1.61 times 10 squared. If you want, you could also say 161. Either of those is just fine by me. They're the same number. Either one's acceptable. The question I always get now is, do we have to give our answers in scientific notation? And the answer is, it depends. So, there are when to give it. If I ask for it, that's the first time. Most important thing, right, is if I'm asking for a number in scientific notation, you should give it to me in scientific notation. And then I would say, rule of thumb, if your number is greater than 10,000 or less than 0.0001, those are good times to use it, because I don't want to have to count all those zeros. So it's easy for me if you give a number in scientific notation if it's going to be very big or very small. Either of those would be ideal. Also, if you feel like it. These are the 3 scenarios. The first 2 are kind of more obligatory. You are welcome to always give an answer in scientific notation. They're just fine with me. Go right ahead. Give it in scientific notation. I'm happy with that. But if you don't want to, that's okay. As long as I'm not asking for it and it's not a huge or tiny number, you're free to use just a regular, give your answer as 3246, whatever, that's fine. If you want to, you could give it as 3.246 times 10 to the third. That would be just fine as well. These are equivalent numbers. I'm okay with either one, unless I ask you specifically for scientific notation. Then you have to give scientific notation, right? So otherwise, they're the same. They're fine with me. Alrighty. Ooh, what a day. So much math. Alrighty. I'm going to give you your weekly participation thing on Thursday, I think. So you're okay for now. You do not need to check in every day. Apparently, some people are doing that. It's totally not necessary, right? We have a weekly participation prompt, which I will announce. So outside of that, you do not need to say, hey, I'm here, if you want to, go right ahead, talk to each other, say hi to each other. That's no problem. But it's not like you're not forced to. So I just want to make that clear. Since for 111, people seem to find the need to check in every day. I check once a week, so for attendance purposes. So you do not need to check every day. All right. So I'm gonna go ahead and so for 111, your labs are gonna start next week. So they're gonna be on Labster. Those will be posted on Canvas for you. So those are going to just be, you do them on your own time. There'll be due dates, but they're just simulations. You just do, there's like a little video you can watch to kind of get used to it. And then you just do the simulations. It's going to tell you, like, pick up the beaker and move it over here or whatever. And you'll just do what it says. And that should be pretty straightforward. So, okay. But I think 101 people, I think you have one due next week, and it's on like lab safety or whatever. So yours are starting a little bit earlier. So, but for 111, you have a little bit longer before I post those. Okay, cool. Sounds good. Enjoy your day, everybody. We'll see you on Thursday. Yes, we're going to talk about unit conversions on Thursday. So that'll be the fun bit there. So, hooray. So we'll get into that fun stuff on Thursday. Okay. Take care, everybody.